Hey everyone, it's Casey from the Montreal Student Network, and today we're going to be talking about cycloalkanes. Now, just by looking at the name, you can kind of break it down and get an idea of what exactly it means. So let's break it down right now. We can see right away we have one familiar word, alkane. And like we've seen in previous videos, an alkane is a hydrocarbon, so only having hydrogen and only carbon, and it has only single bonds. So that's what we're going to be looking at right now, only carbons and only hydrogens with only single bonds. Now the first part we haven't seen yet. It's cyclo. And cyclo, you can kind of get an idea of a cycle, something that comes around and then eventually comes back to the starting point. So it's kind of like a circle. Now you don't really want to think of a circle because none of the shapes we're going to be looking at are circles. As you can see, I have a triangle and a square right here. But you want to get the idea of a cycle, something that comes back and eventually completes the one whole turn, having kind of like a closed perimeter. So basically, it's going to be when you have a bunch of, you have your carbon and hydrogens. It's a hydrocarbon. You have only single bonds, but it comes around and it's connected to each other. So we see this little shape right here. This would represent carbon number 1. This could represent carbon number 2. And this can represent carbon number 3. And then it goes back and it's connected to itself. And something like this, you can obviously see it has 3 carbons and you associate it with the name propane. But like everything in organic chemistry, we can't just simply call it propane. We need to indicate to the reader that it's in fact in a circular formation. That's where we add the prefix cyclo. So this would essentially be cyclopropane. Now you might be wondering what the chemical, when you look at the atoms look like. So we're going to draw it out in expanded structural formula just so you guys can get an idea. So you're going to have your carbons arranged in a triangle like this. And you're going to have your hydrogens. Now you look at each one and you see, okay, they're all connected to 2 other carbons, so they can only have 2 hydrogens on each one. And right there we see that we have 1, 2, 3, 4, 5, 6 hydrogens. So that kind of changes the formula we're used to. For alkanes, we've normally seen the chemical rule of CnH2n plus 2, which means that for every carbon you have, you'll have 2 hydrogens plus 2 more hydrogens. And this little 2 here comes from the fact that you have those 2 CH3s on the end. For this one, since it's coming around and hitting itself, it starts at 1, goes to 2, goes to 3, then goes back to 1. You don't have those endpoints. There's no open ends, so you don't have that extra 2 anymore. So you go down to the rule. Let's change back to orange. Just CnH2n. And we can see right here we have C3H6. You'll have 2 hydrogens for every carbon, and that will be called cyclopropane. You keep that same propane ending, you just add cyclo in the start. And if you want to draw this in condensed, we'll draw it for here. We can see this square, and obviously keeping the similar naming. 1, 2, 3, 4, every end representing a different carbon, and you can probably think of the name right now. It looks like butane, but we'll have to add the cyclo prefix. So cyclobutane. And if you want to draw that in the condensed, rather than drawing it expanded like this, it could simply look something like this. It's essentially the same drawing, except I'm not drawing the lines between the C's and the H's. I'm just linking everything up. Now you can see that I did write H2C. It's the same thing as CH2. I just want to make the line connecting to the C. I don't want to make the line connecting to the H. So that's the only reason I'm drawing this. It's just for visual purposes. But you can essentially see how the bond line, which is these just simple square and triangle drawings over here, relate to the expanded formulas right there. So it's essentially taking the idea of it comes around and it connects back to itself. Right down here we have 2 more. We're not going to draw out the whole thing again because we're getting the idea and I don't want to waste too much of your time. This one we can go and we can count 1, 2, 3, 4, and 5. 5 carbons we associate with pentane, so the cyclo version would be cyclopentane. And now we get to the most popular one. 1, 2, 3, 4, 5, and 6. This is the one you will see so often. Let me lower this a little bit. You will see this so often in the course, it's going to make you sick. Cyclohexane. I'm going to make a video specifically talking about the properties of cyclohexane. It might actually take me a few videos because there is a lot to talk about. It goes on and on and on. It just doesn't stop. You'll have just a whole chapter in my textbook dedicated to cyclohexane, and it just doesn't stop. There's a lot of things to know about cyclohexane, and it's very popular. So this, examining the cycloalkanes, it really helps you understand. If you're having trouble with the naming, now you get to see the actual hexagon. You see it has 6 sides. It's the shape of a hexagon. And that gets you, the hex in hexane comes from hexagon. It's a way to think about it. Hexagons have 6 sides. So when you're looking at a cyclohexane, you can kind of visualize that. And once you start drawing these out a bit more, you'll probably get a better sense of, memorizing them. You won't normally see up to, maybe you'll see a heptane, but that's pretty much as far as you'll go. Hexane is really the one you use the most. So don't worry if you don't know how to draw like a 15-sided cycloalkane. It does get a bit tricky. It doesn't keep getting into a big ring. You end up having like two hexagons or 2 heptagons or 2 octagons right beside each other. I think octagon might probably be the highest you'll ever really need to see. Then it gets a bit more advanced and not something you'd look at in organic 1 unless your teacher likes to torture you. So that's essentially the video right now. We're going to go more in depth and examine the properties of the angles in the next video. So if you want to look about things like torsional strain and angle strain, all those kind of things, we're going to be discussing that later in the next video to see exactly why something like this would not be very stable compared to something like this, that we see this so much more often than we would see cyclopropane, and there's reasons behind that. It's called stability. But I don't want to introduce topics that I'm not going to discuss fully into this video. So that is the video. If you enjoyed the video, please let me know, leave a comment, and if you have any questions, leave them below and I'll answer you guys as soon as possible. Thanks for watching. Have yourselves a great day.